Beneath the surface of our restless planet, forces both ancient and unpredictable are gathering. Volcanic eruptions flare across the globe like warning beacons.
Sleeping Godzilla.
The USGS, it shows the eruption blasting out of a thermal pool.
So much uncertainty in a volcanic eruption.
Volcanic eruptions flare across the globe like warning beacons, and earthquakes rumble through the crust in patterns scientists are still struggling to fully understand. For decades, experts believed they had a firm grasp on the hidden machinery driving our planet's geologic heartbeat. Tectonic plates seemed predictable, their boundaries traced in maps and fault zones, their behaviour outlined in theory. Eruptions, it was thought, followed a script, one that played out along familiar margins or at fault lines that had been monitored for generations. But a new era has dawned, one that brings uncertainty, strange awakenings, and long-dormant giants stirring far from where anyone expected. The Pacific Ring of Fire, a volatile horseshoe of volcanoes and trembling ground, has become more restless than ever. From Alaska's snow-covered peaks to California's parched valleys, volcanic unrest is rippling through 21 volcanoes, setting off heightened alert in research centres from Seattle to Jakarta. Long-standing assumptions are crumbling as satellite data illuminates new patterns and seismic networks record synchronized tremors. Scientists are vigilant. Eruptions appear to be rising and are now occurring in places with little or no record of previous activity. In recent years, dozens of volcanoes have erupted across the Ring of Fire, and sudden, unannounced quakes have rattled regions that were once considered geologically quiet. Each event chips away at the armour of our supposed understanding, as the ground swells and contracts, and magma punches upward through ancient rock. The world's landscapes are rewritten with every blast. The future of continents and of human civilization hangs on the secrets waking beneath our feet. So, what is unleashing this surge in volcanic activity, and how close are we to a dramatic turning point? Chapter 1. Eruption chains shatter assumptions. A single eruption makes headlines, but the near-simultaneous unrest across 21 volcanoes in North America signals something much larger. In recent months, scientists have watched as a chain reaction in volcanic unrest has set off alarms from Alaska's remote summits to the valleys of California. Seismic networks blink red with the increasing activity, a phenomenon not seen in modern recorded history. How could so many volcanoes show unrest together across thousands of miles, seemingly unconnected? Satellites deliver the first clue. Tremors ripple through vast territories, and GPS stations measure ground swelling in patterns that look strangely cohesive. Far below, reservoirs of magma are rising and shifting, driven by deep tectonic forces that don't respect the neat lines of plate boundaries. For decades, volcanologists taught that eruptions tended to be local events, triggered by nearby stress. Now, as if orchestrated by a hidden hand, volcanoes are displaying coupled unrest, suggesting the need to see entire tectonic regions as interconnected systems. If volcanoes can awaken together, what chain of events could erupt next? Chapter 2. Unknown volcanoes break their silence. Could history be hiding violent secrets beneath quiet hills and calm forests? Beneath layers of soil, ice, and vegetation, volcanoes with no written history have suddenly begun to stir. In regions where generations lived unaware, the earth can split open with power that no one anticipated. Why are volcanoes with no known record erupting, and what clues might have been missed? Geological records offer a sobering truth. The planet keeps secrets well. In places like the Pacific, South America, and Indonesia, eruptions from volcanoes with no prior observed activity have occurred approximately every 7 to 10 years. Their long silence is not safety, but illusion. Dormancy does not guarantee extinction. By analyzing ash layers and core samples, scientists are reconstructing histories that stretch back before written records, revealing cycles of major volcanic awakenings. The evidence suggests that periods of calm are simply intervals between dramatic eruptions, and in some regions, that cycle may be shortening. What else is waiting beneath the surface to surprise us? Chapter 3: The Ring of Fire's Secret Stress. Encircling the Pacific, the Ring of Fire marks the planet's most turbulent frontier. Roughly 3/4 of all erupting volcanoes and 9/10 of the world's earthquakes take place around its rim. But even as geologists have mapped its dangerous seams, new research reveals unseen forces building far below. How does stress build so quietly and release so violently without warning? Modern satellite and seismic data reveal that tectonic stress is not confined to known fault lines. Instead, it distributes itself across broad swathes of crust, rubbing, grinding, and warping the Earth above. Movement in Alaska can send subtle tremors through California. A silent shift under Chile can influence distant fault zones. This interconnected tension turns what were once local threats into regional, even global risks. Tiny fractures can send ripples outward, pressure leaping across plate boundaries as it seeks a path. When released, these pent-up forces can trigger not just local earthquakes or eruptions, but widespread disruption. Are our maps of geological risk truly complete, or only a surface sketch of deeper processes? Chapter 4: Red Alert, the 53 eruptions. A number that once seemed fantastic is now manifest. Over 50 volcanoes observed erupting around the Pacific Ring of Fire in recent years. Such widespread activity has prompted meteorological and geological agencies to issue urgent alerts. Why are so many volcanoes erupting around the same time, and what has changed in the Earth's deep interior? The answer may be a combination of factors: increased tectonic stress from shifting plates, magma rising in areas previously considered stable, and evidence of deep-seated planetary changes. Each volcano is shaped by these pressures, but now, boundary zones that once separated volcanic centers appear to be less predictable. This unusual confluence of events signals to scientists that old models, developed during decades of relative stability, may not fully capture the planet's current dynamics. Can humanity adapt quickly enough to an increasingly unpredictable Earth? Chapter 5: Volcanic Soil, the Paradox of Destruction. Volcanic eruptions can devastate communities, but in their aftermath, they also sow the seeds of renewal. How do violent eruptions foster new life on Earth? When lava and ash settle, the land beneath is eventually transformed. Lava, once liquid and lethal, cools into rock rich in minerals. Large-scale eruptions break down and redistribute these minerals over time, creating some of the world's most fertile soils. Major agricultural regions, such as those in Java and the Andes, owe much of their richness to ancient volcanic activity. The paradox is clear: the more explosive the destruction, the more dramatic the long-term renewal. But this renewal arrives on a hazardous schedule, and with cycles of eruption shifting, the reliability of this natural fertilizer becomes less certain. If we depend on the product of past disasters, what happens if the rhythms change? Chapter 6. Earthquakes in unexpected places. What if the ground beneath, believed to be stable, is quietly storing potential energy? Earthquakes appear now even in regions with no major mapped faults. Why are significant earthquakes occurring in areas once thought geologically tranquil? Classic tectonic theory held that earthquakes mostly cluster at plate boundaries, where plates collide or slip past each other. But more recently, scientists are noting tremors and even significant quakes deep within continental plates, far from recognized boundaries. Volcanic unrest can redistribute the accumulated stress, so that internal regions also feel the strain. This can fracture rock unexpectedly, sending tremors and even major shocks through areas with little or no prior seismic history. If quiet ground is no guarantee of safety, what new risks must we prepare for? Chapter 7. Satellite eyes unveil the unseen. Satellites have become the planet's vigilant sentinels, recording small shifts invisible to human observation from the ground. How are satellites revealing new threats lying beneath the surface? High-resolution sensors now detect swelling ground, subtle changes in slope, and tiny shifts in the Earth's surface that precede eruptions. NASA and other agencies use this data to monitor volcanic regions in real time, creating moving models of strain and potential eruption. What is most surprising, many of these warning signs do not always occur near long-known volcanoes. New domes, uplifts, and changes in terrain emerge far away from catalogued volcanic centers. These findings reveal threats that had long lain hidden beneath seemingly ordinary landscapes. Are we ready to act on what these orbiting sentinels reveal? Chapter 8. Mega earthquakes, the next domino. Some earthquakes are so massive that they shake entire continents and permanently alter coastlines. The scars of these titanic ruptures are written in layers of earth and history. Is the recent rise in volcanic and seismic activity a sign that the next mega earthquake could be approaching? Research points to a troubling pattern. Stress building beneath volcanoes can migrate to nearby faults, potentially setting the stage for truly massive earthquakes. Historical records show the devastating power of Cascadia in 1700, which sent tsunamis across the Pacific, or the magnitude 9.0 Fukushima event in Japan. These megaquakes often come after or are associated with periods of volcanic unrest, though precisely predicting this relationship remains one of science's greatest challenges. Current unrest may be another chapter in the Earth's preparation for such rare but catastrophic events. How much warning will this time grant us before the next megaquake strikes? Chapter 9. Microplates and the shattering crust. The Pacific Plate was once thought to be a near unbreakable monolith, but evidence now shows its edges fraying and segments breaking away. How do these fragments, the microplates, change the rhythm of earthquakes and eruptions? Geologists have traced entire mobile blocks breaking from larger plates, forming microplates at triple junctions where tectonic chaos rules. As stress builds along their boundaries, these fragments can rotate, collide, or slide, creating zones of volcanic activity and earthquakes that defy older expectations. This process is observed under the oceans now, as the Pacific's outer edges grow increasingly complex. The rearrangement of these blocks may generate new zones of instability unlike any previously mapped. Could the next major geological event emerge from these evolving fault lines? Chapter 10. Hidden hotspots. Magma's stealthy ascent volcanoes were once believed to erupt only along mapped faults or rifts, but in reality, they can form above powerful mantle hotspots, ignoring surface structures altogether. How do volcanic hotspots pierce even the thickest stretches of crust? In Hawaii, Samoa, Tahiti, and elsewhere in the Pacific, plumes of hot rock rise directly from the Earth's mantle, melting their way through the overlying plate and building linear chains of volcanoes. The Hawaiian Emperor Chain, shaped by such a hotspot, provides a dramatic example of persistent geological activity changing the ocean floor over tens of millions of years. These plumes are unhindered by the tectonic plate above, creating volcanoes and islands in locations unconnected to faults. Are we prepared for eruptions to start where no warning signs suggest they should? Chapter 11. The Farallon Plate, Lessons of Collapse. The Pacific's tectonic instability echoes a dramatic history. Even vast, ancient plates can vanish. What can the story of the disappeared Farallon Plate teach about the Pacific Plate's future? Once, the Farallon Plate spread across much of the eastern Pacific. Over millions of years, subduction zones along North America consumed it, fragment by fragment. Its remnants, the Cocos, Nazca, and Juan de Fuca plates, drive instability and hazards today. For instance, the Juan de Fuca plate is now the engine behind the Cascadia subduction zone, responsible for some of North America's largest seismic risks. The dismantling of the Farallon Plate is a reminder that no part of Earth's surface is permanent. Pieces endure and become sources of new hazards, potentially the fate awaiting the Pacific Plate. Are we witnessing the early stages of another grand tectonic transformation? Chapter 12. Unpredictable chaos at plate boundaries. Earth's most dynamic forces meet at plate boundaries, but instability can also come from within. How does internal fracturing increase the risks at already volatile edges? The Ring of Fire's subduction zones, where plates dive beneath their neighbours, are the sites of nearly 75% of all active volcanoes and 90% of earthquakes globally. When strain builds in the plate interiors, it can amplify instability at these boundaries. Subtle changes within the plates can intensify the eruption and earthquake hazards along their edges, driving unpredictable patterns of danger. The effect? A multiplying of risk precisely where populations and infrastructure are most concentrated. Can our coastal communities withstand the rising tide of internal and external geologic stress? Chapter 13. The Science of Synchronized Unrest. No longer can eruptions or quakes be viewed in isolation. Mounting evidence shows geological events are more interconnected than ever imagined. Why are volcanoes and earthquakes acting together in ways that defy classic models? Traditionally, each event was treated as its own crisis, but recent data suggests otherwise. Stress, magma movements, and heat can transmit through networks spanning thousands of kilometers. One eruption may relieve pressure in one area, while another increases it elsewhere. Similarly, a quake in one region might subtly tip the balance, contributing to volcanic unrest in another. These chains of events, sometimes subtle, sometimes dramatic, require scientists to rethink how the planet's geologic systems interact on a global scale. Are we only glimpsing the beginnings of a more interconnected geologic future? Chapter 14. Soil's Memory, Unexpected Fertility. From volcanic ashes, a bounty arises. Some of the world's richest soils were forged in disaster. Can humanity's dependence on volcanic soils endure if cycles of destruction and renewal grow less predictable? Throughout history, civilizations have flourished on volcanic slopes, their wealth and sustenance tied to the black, mineral-rich soils left by past eruptions. In Java, the Andes, and parts of Central America, the legacy of ancient volcanoes feeds millions. But as volcanic rhythms shift and eruptions occur in unexpected places or intervals, the pattern of soil renewal also changes. Unpredictable eruptions can reshape agriculture, sometimes enriching land, sometimes burying it. The cycles that civilizations depend on have always been uneven, but mounting unpredictability threatens to upset this fragile balance. How resilient are we if the clock of volcanic renewal grows more erratic? Chapter 15. Triple Junctions, Factories of Fracture. Where three tectonic plates intersect, the Earth is at its most volatile. How do triple junctions drive rapid geological change? These intersections, triple junctions, are dynamic places where immense stress tears plates apart and forges microplates. Volcanic and earthquake activity frequently occurs here as stresses build and release in unpredictable patterns. The fragmentation of the Farallon plate and ongoing changes in the Pacific began at such points of stress. Triple junctions are the sources of rapid crustal reshaping, and as evidence accumulates, scientists see them as key drivers of the new geologic complexity now being observed across the Pacific Basin. What surprises might still emerge from these high-energy crossroads? Chapter 16. Eruption Forecasts in Flux. Despite decades of progress and sophisticated technology, forecasting volcanic eruptions and earthquakes is now confronting new limitations. Are current models for detecting disaster able to keep pace with accelerating change? Volcanologists and seismologists have developed elaborate monitoring networks and alert systems, but the upsurge in previously unmonitored simultaneous eruptions and unexpected quakes is exposing the gaps in these models. Accelerating change means that warning signs may be missed, or that the systems cannot issue warnings in time. With the USGS and international agencies issuing more alerts than ever, it's clear that models based on past eruptions may no longer be enough. This has scientists rethinking how disaster prediction and preparation must evolve in a rapidly changing world. Can we build warning systems nimble enough for the planet's shifting tempo? Chapter 17. Recycling Catastrophe, Renewal or Ruin. Earth's cycle of destruction and rebirth is a fundamental part of its geology, but what happens when disaster comes faster than recovery? The pattern of renewal is woven into the planet's fabric. Lava flows build new land, volcanic soils restore agriculture, and earthquakes reshape rivers and valleys, creating new ecosystems. But rising frequency and unpredictability, fueled by human-induced changes such as pollution, urbanization, and possibly climate shifts, threaten to push natural recovery past its limits in some regions. In areas where volcanoes erupt too often or too violently, recovery may take centuries, with scars left on landscapes and societies. The balance between destruction and renewal is never fixed, and humanity's future may depend on how well we adapt to these adjustments. What happens if the rate of upheaval outpaces recovery, by nature or by human action? Chapter 18. When the plates finally break. The ground beneath us is always changing. Every tremor and eruption adds a chapter to the planet's continuing story of transformation. The Pacific Plate, the largest on Earth, is restless. Its boundaries grow more complex. Microplates separate from its edges, dormant volcanoes awaken in landscapes once forgotten, and signals from the deep reach the surface with growing urgency. No tectonic plate is eternal. When major plates fracture and disperse, the aftershocks ripple far beyond their immediate borders, affecting millions and remaking nations and continents. The history of the Farallon plate proves that even the mightiest will be reshaped over millions of years, sometimes abruptly. Today's rising volcanic and seismic unrest may be harbingers of these large-scale shifts. The pressing question facing science, governments and communities is clear. When the plates finally break, what will our world become? If you want to stay informed about Earth's hidden forces, the mysteries beneath your feet, and the science that seeks to understand them, subscribe for more explorations of our changing planet.